back. You are watching the section on naming, measuring, and drawing angles. There's a couple of things we need to know about angles, the basics. We always like to lay out the basics before we start. And so what I've drawn over here is an angle that is S, R, and T. It has those points on there. As you can see from previous sections, we know that there are a couple of rays involved, there's a couple of points involved, and so let's see how all that fits together. The technical definition of an angle is a figure formed by two rays or sides with a common endpoint. Well, if we look at exactly what that common endpoint looks like, let me pull up some colors here for us. And if we look at what that common endpoint looks like, it is going to be this point here, that is R. R is that common endpoint because it's shared by S, R, and it's shared by RT. Okay, so that's the common endpoint. This is also called the vertex. Okay, so the vertex is called that common endpoint. The vertex, you can think of it as the point of the angle. Okay, the point of the angle is the vertex. The interior of the angle is the stuff in between the sides. So this is the interior. And this would be the exterior. Exterior. That's all this stuff on the outside. Okay? And so we need to talk about naming angles. Okay? So when we name an angle, you can call it a couple of different things. The name of this angle could be, it could be angle R, or you could use the little angle symbol R. You could also call it, so this is in quotes, this is what we would say, or we could call it angle SRT, or angle SRT, or you could call it angle TRS. I want you to notice the order that I'm going in. Or the fourth thing we could call it, because it's got this one right here, is angle 1, or angle 1 would be the technical notation of it. Now, because this angle is standalone, it has these 3 points, there's no other angles connected to it, there's no other angle that it could possibly be, all 4 of these apply. But if we take this note here, you cannot name an angle by its vertex alone if that point is a vertex of more than one angle. Notice there's only one angle attached. For example, if I had this S, T, and there was V, I couldn't say angle R because angle R could be this one over here, it could be this big one here, or it could be the whole thing. So it has to be the point of but one angle. So in this case, we must use all 3 points to name the angle, and you must use the middle as the vertex. Notice, R is in the middle, R is in the middle. The vertex is in the middle because you go in order. Geometry is an order kind of a thing. Okay? Let's look at example 1. Naming angles. I've got this figure here that has 4 points on it, and there are a number of angles. Let's name 3 angles in the figure. Well, first of all, there are a lot of angles in this figure. So the first one I'm going to name is QTR. Notice I put the little angle symbol out front. Okay, angle QTR. So that's this one here. What about this bottom one? Well, I could also call it angle RTS. And there's another angle. What about the big angle? I could call that angle QTS. So there's 1, 2, 3 angles. Now, but some of you out there are thinking, but there could be alternate ways to name these angles. You are right. Because up in this top example, notice, we called it SRT, but we also called it TRS, so we don't necessarily have to go in that order. See if you can, in letter B, name 3 alternate ways to name those angles. Okay? The measure of an angle is usually given in degrees. We know this. A degree, there's 360 degrees all the way around a circle, so 1 degree is 1/360th of a circle. That's what a degree is. And the protractor postulate has to do with the protractor, one of which you see on your screen and the other you can see right here. I've got this giant protractor here that's used on the board. And around it you can see the degrees listed. Okay? Many of you have probably used a protractor before, and there's a big giant postulate that describes what you do with a protractor. And it says, given AB, so a segment, and point O on AB, all rays that can be drawn from O can be put under 1-to-1 correspondence with a real number 0 to 180. If we have a straight line, AB, okay, let me draw in AB down here. Scoot this down just a little bit. So if I have a segment A, and here's B, AB. So AB extends straight across like that. I can put the numbers from 1, so here's B at 0, so 1 all the way around. Look, notice I'm looking at the top numbers, to 180. And if I draw a random ray out this way, and I just call it C for giggles, notice it lines up with 120. It'd be like this. If I've got a straight across line right here, and I drew this line out to 120 here, you can put those lines on these degree marks and you can measure the angle. That's all it's saying. And from that, we get different types of angles. Well, you guys pretty much already know these. Acute angles are small. In comparison, how small? They are angles, I'm abbreviating here, less than 180 degrees. Okay, so they would look like this. They are cute, little cute angles. So this would be less than 180. Okay? Cute. They're real cute. They're little. They're less than 180. Right angle. Looks like this. Stands upright. 90 degrees exactly. Okay? 90 degrees exactly. No more, no less. Obtuse, they kind of look in general like this. Okay? Bigger than 90. Less than 180. But you're thinking to yourself, what about this acute angle? It's less than 180 as well. It's less than 180. In fact, it's less than 90. So you'll notice everything we're doing here is less than 180 right now, because our protractor is measuring 180, and 180 is the limit of all of these. Okay? Acute angles are less than 180. In fact, they're even less than 90. Obtuse angles are also less than 180, but they're bigger than 90. Okay, so cute angles are cute. They're smaller than 90, so they're smaller than this 90-degree angle, but they're bigger than 0. Obtuse angles are bigger than 90, but less than 180. A straight angle is just like it says. It's straight. It's 180 degrees exactly. That's how it goes. So there's only 4 types that we're going to talk about in geometry right now. Everything is 180 or less. 180 is significant. It's called a straight angle. 90 degrees is a right angle. Obtuse is between 90 and 180. Less than 90 would be an acute angle. Okay? Measuring and classifying angles. Let's look at how this works. Based on how these letters are arranged, you're going to tell us what angle we're actually talking about. So I'm going to do the first 3, and then I'm going to give you these 2. Let's look at AOD. Angle AOD. A note on measurement. AOD is going to be equal to a measurement. So what we would have to say is the measure of angle AOD is read like this. Measure of angle AOD. And so when we're talking about the measurement of an angle, we have to put that little m in front. Okay, so the measurement of angle AOD looks like this. We start at A, we go to O, and we go to D. So we're really talking about this. Well, where do we start? We start at A. So where are we going to have to start? Which scale do we use? Well, you'll notice you have these two scales here. So it says 10 and 170, and on here it's 0 and 180. Well, where should we start counting from? 180 or 0? Let me think. Oh yeah, 0. So we're going to start with A at 0. And so that's going to be the bottom scale. So you have to follow this bottom scale to measure this angle. So AOD, we're going to go from 0, and we're going to use the bottom scale. So D is, and it's hard to see here, but let's look out where it actually crosses. It's between this 10 and 20. So the 10 corresponds to 170. The 20 corresponds to 160. So this is going to be 165. Okay, I know that's a little hard to see because it's not exactly straight, but you have to look out to the end to see where it crosses the tick mark and then kind of line it up. Let's do another one. COD. So the measure of angle COD. Let's see where this lines up. So C is here, O is obviously this middle, and D is here. Well, this is going to present a problem because it doesn't line up with 0. So which scale do we use? Well, let's see if it makes a difference. COD starts at between 100 and 110. So it's going to be from 105 to, and if we go out, we'll use the top scale, to between 10 and 20. So this is going to be to 15. So it goes from 105 to 15. Well, obviously, we could count the numbers between that, but let's just subtract. So 105 minus 15 equals 90. Well, if we were to count this, we could start at 15. This would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90. Okay, so we could count, or we could subtract, or there's a little trick here. You can't really do it on this, but what if we tried to line it up so that C was lined up with 0? That would work. Okay, if we could actually manipulate this and turn it and do all that kind of stuff, we'll do that later in class. Okay, let's look at BOA real quick, and then I'll give you 2 to do. So B, let me get a different color here. Let's get a pinky color. So B, you can't really see that, can you? Let me get a light blue, maybe that'll help. So B is here, and then O, and then A. Well, so see, they're trying to trick us because they're trying to go backwards. Does it matter where I start measuring from? Is angle AOB equal to angle BOA? Well, it doesn't really matter which way I go to start counting because the degrees are going to be the same. And so the measure of BOA is going to be equal to, let's see, if we consider this 0, and this goes to 140, oh, no, 0, so I have to use the inside scale, 0 to 40, this would be 40 degrees, okay? That's how that works, all right? So that's the basics of angle measurement. I'd like for you to try D and E by yourself, and we'll talk about those in class if you have any questions. One last kind of thing here, congruent angles. Let me draw 2 angles and talk to you for a second about this. Okay? Congruent means same size, shape. So they are the same. If it's congruent, it looks like this. So the mark for congruent, let me scroll this up just a little bit. Okay, congruent is this. That's how we say congruent. It's an equal sign with a little squiggle above it. And the reason why we say that is because it doesn't just mean equal size, it means equal shape. And so if I draw 2 angles here, let me try to get them a little bit closer just for your viewing ease. That's not closer. Okay, so let's look at this. What if I labeled this angle 1 and angle 2? And I said angle 1 is congruent to angle 2. Okay? So I could say that, and I'm going to say that these are same size. And what that means is the measure of angle 1 is equal to the measure of angle 2. This is talking about numbers, like 65 degrees equals 65 degrees. This is talking about shape. So that would mean that if you put angle 1 on top of angle 2, they'd be the same. So equal sign is talking about the number associated with it, like length or distance or degrees, and the congruent sign is talking about the shape, not just the size, but the shape. And so I need an easy way to show that these two are congruent. Well, that's going to be taken up by arc marks. So what I can do is this. I can say one tick mark, one arc mark means that these are congruent. So this means congruent angles. So what if I drew a third angle down here and I called it angle 3, and I didn't know anything about it, but I had this little arc mark on it. Well, this arc mark means that angle 1 is congruent to angle 2 is congruent to angle 3. They're all the same size. So whatever angle in this situation, this problem right here, this scenario, whatever's marked with one arc mark, those are all congruent. That's the basics of angle measurements, guys. Thanks for watching. If you have any questions, write them down in the margin of your notes, and we'll talk about them in class. Thanks for watching.